So what are the learning objectives here? By the end of this chapter, you should be able to understand the methods of obtaining the best solution using the limited resources, and you should understand how to develop the inequations which are based on the information given and represent these inequations graphically, and finding out the common region which satisfies all the inequations. The common region satisfying all the inequations is known as feasible region. Welcome to this chapter on inequalities. Now, in today's world, the managers come across so many problems where they have to make decision. Now, the resources that are needed are not in abundance, they are scarce. So these managers have to, on daily basis, make decisions where the limited resources have to be utilized. So from time to time, these managers have to find ways and means of utilizing these limited resources to the best of their ability, meeting their objectives. Now, these resources which are limited, they have to be utilized to the best of the manager's ability so that they are able to make decisions on right time. So what we are going to do here is, we are going to use several linear inequations in two variables. You are going to develop these linear equations in two variables depending upon the available information. Now we speak about linear equations, and that too linear equation in two variables. Now a linear equation in two variables has infinite solution. What is a linear equation in two variables? It is of the form ax plus by plus c equal to 0, where a and b are not equal to 0. This linear equation in two variables, that is ax plus by plus c equal to 0, has infinite solutions. Infinite solutions means what? When we represent this linear equation ax plus by plus c equal to 0 on a graph paper, it will give us a straight line, because the graph of a linear equation is always a straight line. Now every point on the graph of this linear equation in two variables, that is ax plus by plus c equal to 0, gives the solution of the equation. Suppose we take a point P alpha beta which is on the graph of this linear equation. That means x is equal to alpha and y equal to beta is the solution of ax plus by plus c equal to 0. And we all know that we need minimum 2 points to plot a linear equation in two variables. So if we take any 2 points alpha 1 beta 1 and alpha 2 beta 2, which lie on the equation ax plus by plus c equal to 0, and when we plot these 2 points on graph paper and then joining these 2 points, what we get is nothing but the graph of equation ax plus by plus c equal to 0. Now let's see or look at the examples where of some equations, and let's see how to represent them graphically. To begin with, taking a very simple example, draw the graph of the following equations. The first one is x equal to 0. Now the equation x equal to 0, what does that mean? That for any value of the ordinate, when I say ordinate, I am talking about y-axis. When I say abscissa, I am talking about x-axis. So the equation x equal to 0 means for any value of y, the ordinate, your x will always be 0. And x coordinate is 0 on the y-axis. So the equation x equal to 0 represents y-axis. So this is the graph of the equation x equal to 0. X equal to 0 is your y-axis as shown in the graph. Similarly, when I say y equal to 0, what does that mean? For any value of x, your y is always equal to 0. Example 3, 0, 5, 0, minus 3, 0. Minus 3 means x on the x-axis, your x value is minus 3 and y equal to 0. So what is the equation? Y equal to 0 is nothing but your x-axis. Now I have this equation x equal to 3. What does this mean? X equal to 3 means for any value of y, your value of x is always 3. That is, the x coordinate will always be 3. So this line will pass through the point 3, 0 and it will be parallel to your y-axis. So x equal to 0 is an equation and its graph is parallel to y-axis, and this line will pass through the point 3, 0 as shown in the graph. Now we take the next equation, y equal to minus 5. Y equal to minus 5. Minus 5 is a constant. So the value of y coordinate will not change, but the value of the x coordinate will change. So y equal to minus 5 is a line which will be parallel to x-axis and passing through the point 0, minus 5. That means y equal to minus 5, for any value of x, your value of y will always be minus 5, which can be shown in this graph. You have origin denoted by 0, 0, 0. That is, the origin is always named as O with the coordinates 0, 0. You have x, O, x, that is x 0. When you move from 0 right hand side, it is your positive x-axis. When you move towards the negative, it is negative x-axis. Similarly, from the point O, origin, if you go upward, it is positive y-axis. If you go downward, it is negative y-axis. So your line or equation y equal to minus 5 passes through the point A, bracket 0, minus 5, bracket close, which is nothing but a line parallel to x-axis passing through the point 0, minus 5. So the next equation is y equal to minus x. So let's tabulate the values of x and y for y equal to minus x. So when we take x equal to 2, we get y equal to minus 2. And when we take x equal to 4, we get y equal to minus 4. So this is how we tabulate the values of x and y. The points required to draw the graph of y equal to minus x are 2, minus 2 and b, minus 4. So to plot the graph of y equal to minus x, we need these 2 points, 2, minus 2 and 4, minus 4. So when we plot these 2 points on the graph paper and join them with a line with the help of a scale and a very well sharpened pencil, you get this graph, which is passing through the point 2, minus 2 and 4, minus 4 as well, and it also passes through the origin, that is 0, 0. So this is how we plot the graph of y equal to minus x. Here we have taken the scale on x-axis as 2 square centimeter equal to 1 unit, and on y-axis also we have taken 2 square centimeter equal to 1 unit. So this is how the graph of the equation y equal to minus x looks. Now we go to the next question. Draw the graph of the following equations, and in each case check whether x equal to 2, y equal to 5, x equal to minus 1 and y equal to 3 are the solutions. So we take the first linear equation in 2 variables, that is 2x plus 5y equal to 13 given to us, and we tabulate the values of x and y for the linear equation 2x plus 5y equal to 13. We need only minimum 2 points to draw the graph of a linear equation, but here we have taken 3 points. So if I take x equal to minus 1 in the linear equation 2x plus 5y equal to 13, I get y equal to 3. And if I take x equal to 4 in 2x plus 5y equal to 13, we get the value of y as 1. And if we take x equal to minus 6, we get the value of y as 5. So we get 3 points, minus 1, 3, 4, 1, minus 6, 5. And we call them as A, B and C respectively. So you're going to plot these 3 points on the graph paper and join them with the help of a scale and a very well sharpened pencil, as shown in the graph. So this is the graph of 2x plus 5y equal to 13. It passes through the points minus 6, 5, minus 1, 3 and 4, 1 as we tabulated in the table. Now we want to check whether 2, 5 is a solution of 2x plus 5y equal to 13. So we plot the point 2, 5 on the graph paper. From this point, draw a line parallel to the y-axis. It intersects the y-axis at point 0, 5. And from the same point 2, 5, we draw a perpendicular line to x-axis and parallel to y-axis. It intersects at the point 2, 0. This point 2, 5 does not lie on 2x plus 5y equal to 13. Hence, it is not a solution. That is, x equal to 2, y equal to 5 is not the solution of 2x plus 5y equal to 13. The next point given to us was x equal to -1 and y equal to 3. Now we plot this point -1, 3 on the graph paper, which is already plotted. So we draw a line perpendicular from this point to the y-axis, which will be parallel to x-axis, and from the point -1, 3, we draw a line perpendicular to x-axis, which will be parallel to y-axis. Since this point -1, 3 lies on the line 2x plus 5y equal to 13, it means x equal to -1 and y equal to 3 is a solution of 2x plus 5y equal to 13. Now the second equation given to us is 2x minus 3y equal to -11. So let's tabulate the values for 2x minus 3y equal to -11. So when we take the value of x as -1 and put in 2x minus 3y equal to -11, we get the value of y as 3. When we put x equal to -4 in 2x minus 3y equal to -11, we get the value of y as 1. Similarly, when we put the value of x as 2, we get the value of y as 5. So we get 3 points, that is -1, 3, -4, 1 and 2, 5. We call them as points A, B and C respectively. So we plot these 3 points on the graph paper and join them with the help of a scale and a well-sharpened pencil. So here also we have taken the scale on x-axis as 2 square centimeter equal to 1 unit. Y-axis also same scale, 2 centimeter equal to 1 unit. And when we plot the points -4, 1, -1, 3 and 2, 5 and join them with the help of a scale and a very well sharpened pencil, this is what we get. And this is the graph of 2x minus 3y equal to -11. Now the next step is to check whether 2, 5 and -1, 3 are the solutions of this linear equation in two variables, that is 2x minus 3y equal to -11. Since both the points x equal to 2, y equal to 5 and x equal to -1 and y equal to 3, both the points lie on 2x minus 3y equal to -11, we conclude that x equal to 2, y equal to 5 and x equal to -1, y equal to 3 are the solutions of 2x minus 3y equal to -11.